Hey, so this is lesson 4, and now we're going to talk about equilibrium. Our objectives are to define equilibrium and explain how it is established and maintained in a system, and you will also identify the two types of equilibrium. So let's start. Equilibrium, how can we remember what this means? Well, we say equal rates, and we're going to put that going down, equal rates, and that will help us. So equilibrium is actually when the rate of the forward reaction is equal to the rate of the reverse reaction. Some physical and chemical reactions are capable of reaching equilibrium. And equilibrium will occur when the rate of the forward reaction equals the rate of the reverse reaction. In a closed system, this is very important, so it has to be closed. When equilibrium is reached, it does not mean that the reactants and products are of equal quantities. This is very, very important. So equilibrium is represented by double arrows that look like this, okay, instead of a single arrow. This allows us to illustrate that the reactions are proceeding in both directions, forward and reverse. Equilibrium is dynamic, and that's why we say dynamic equilibrium. It is dynamic, which means that it is constantly changing or fluctuating in either direction. Okay? Equilibrium means that reactant and product concentrations are constant. But not equal. So they're going to remain constant going forward and reverse, but they will not be equal. Equilibrium does not mean that reactant and product concentrations are equal. Very, very, very important. Okay, I would memorize that. So what I want you to do right now is answer these two questions, or actually define equilibrium in terms of reactant and product concentrations based on what I just told you, and then define equilibrium in terms of forward and reverse reaction rates. Okay, so let's go into types of equilibrium. You will have answers for me in class. All right, types of equilibrium. So they all occur in closed systems. And it's all about the equal rates. That's all it's about. So physical equilibrium is an equilibrium that involves physical changes, so solid to liquid to gas. Okay, those are physical changes, or phase equilibrium, or solution equilibrium. So we have phase equilibrium, which occurs during a phase change. And here are some examples. Solid to liquid, and then I'm going to do the double arrow, solid to liquid, okay? Rate of melting is equal to the rate of freezing, and that's why they both have the same temperature in a sealed container at 0 degrees Celsius. Another one would be a liquid, and I'm just going to abbreviate my arrows here, okay? So a liquid to a gas is when the rate of evaporation is equal to the rate of condensation at 100 degrees Celsius. So we know that. This is the boiling point, okay? Boiling point. That's melting and freezing point, okay? So sometimes you can do your arrows like this instead of actually writing them out. So this is my abbreviated way of doing it, okay? Abbreviation. So shortcut. Any way you can, that's what chemists like to do. So solution equilibrium. It occurs at a solution's saturation point. So this is why we did solutions before we did this unit, saturation point, when it falls on that curve. Okay, so the rate of dissolving is equal to the rate of crystallization. And here's an example for you. We have sodium chloride, NaCl, as a solid, and I'm going to make this a forward and reverse reaction, becomes NaCl aqueous, saturation point. Okay, so the rate of dissolving is going to equal the rate of crystallization, and therefore becomes an aqueous solution. Okay, crystals are not produced. So now you have a chemical equilibrium, which is the second type, and that's when the rate of the forward reaction is equal to the rate of the reverse reaction. Or the rate of breaking bonds is equal to the rate of forming bonds. That is what chemical equilibrium is. Reactions, okay? So when we talk about some sort of reaction, it's a chemical equilibrium. When we talk about phase change, it's a physical equilibrium. So here in this diagram, I know it's hard to see and it's not very important, but the forward process, A plus B, is going to form C plus D, decreases in rate as time increases. The reverse process, same thing, C plus D is going to form A plus B and increases as in rate as time increases. Eventually, when those rates are equal, okay, reaction rate here, when they're equal, then the whole system will be at equilibrium and the forward and reverse rates are equal. So that's what we're showing you here. So here's a forward process, here's the reverse process. Once they become equal over time, then it is at equilibrium. So that is the equilibrium state. All right, so that actually finalizes lesson 4. Please make sure that those 2 questions or things that I asked you to do for defining equilibrium are complete for class. And jot down any questions that you might have about these diagrams. I'd like to clarify anything for you in class.